live in lower Louisiana. We live on the coast. We live near the marsh. We live near the swamps.
We do have areas that do flood down here, so we have to acknowledge the floodplain maps.
Our ground has changed, our marshes have changed, our levees have changed.
In 2002, Congress created the Flood Map Modernization Program known as MapMod. The goal of MapMod is to update all of the rate maps used by the National Flood Insurance Program from the existing paper maps to a new digital format. FEMA's schedule for digitizing Louisiana flood maps was aggressive. By 2005, some Louisiana coastal parishes already had preliminary flood maps. Then Hurricanes Katrina and Rita brought coastal mapping to a standstill. The damage caused by Katrina and Rita made it obvious that coastal mapping assumptions had to be updated. The federal government launched a project that combined the resources of FEMA, the Army Corps of Engineers, the state of Louisiana, and leading scientists from across the nation to develop a new comprehensive approach to identify the current flooding risk to coastal Louisiana. One of the major advances in mapping technology selected by the team is known as LIDAR. It's a revolutionary way of capturing topographic information using ranging laser devices calibrated to ground-based GPS.
When you start looking at the LIDAR data, you see every little bump and nook and cranny that's down on the ground. Any kind of previous surveying technique was never able to give us this kind of detailed data. Right now we can get down to about 1 by 1 foot pixels and that tell us how high the ground surface is.
Using LIDAR data, a computer modeling program can then calculate the patterns floodwater will follow during intense events. The Louisiana mapping team selected ADCIRC, the Advanced Circulation Model, to calculate storm surge for the Louisiana coast. Scientist Johannes Westerink leads the ADCIRC team.
The way ADCIRC works is we start with the equations that describe flow, and they really are a mathematical representation of the processes occurring. There's many things that force this system. There's the tides, there's riverine flow, there's of course the wind, the atmospheric pressure, and there's also wave action that forces flows. And so we actually go all the way from Nova Scotia to Venezuela and model everything to the west of that. Each of these little areas that you see are triangles, and they're connected to each other through a vertex point. Each one of those points has an algebraic equation, a mathematical equation that's actually solved on the computer. And in fact, in this model, we have about 2.1 million points, computational points, each of them computing surface water elevation and the currents, or the speed of the water, in the X and Y directions. But we have 85 to 90% of those points in and around southern Louisiana and Mississippi. There's more complexity, more gradients, more changes in space as you get onto the continental shelf. But then when you get into the floodplain and the rivers and the leveed systems and the gullies and the channels and the tremendously intricate complexities of the geographic system that we see in southern Louisiana, then you need to add a lot of resolution in order to capture these details. Essentially, force is equal to mass times acceleration on a local element. So that's what we're keeping track of, momentum and mass. The flood maps are based on not only the physics of the water flow and of the storm surge, but they're also based on getting a correct statistical representation of the kinds of storms that can happen. About 160 storms were selected for southeastern Louisiana. Another set was selected for southwestern Louisiana. We're able to really simulate not only the high water, but also the surge, the rise in the water, and the recession process. And that gives us a very good picture of what would happen in southern Louisiana for all the possible storms that can strike. We run recent storms to validate the models. We're very confident that we have a good physical representation of what happens during storms.